Okay, this is Unit 6, Lesson 14, Finding Solutions to Inequalities in Context. And our focus question, how can you write an inequality to represent a situation? Okay, let's take a look at the first one. Solutions to equations and solutions to inequalities. Solve negative x is equal to 10. So if I put a 10 in for x, if I said x was equal to 10, that would mean negative 10 is equal to 10. So that's not true. So this is a little bit confusing if they have a negative sign in front of the x. This means negative whatever x is. So if we say negative value of the variable, so the value of the variable would have to be negative 10. A negative 10 is equal to 10. Okay, this is like negative 1 times negative 10. Okay, find two solutions to negative x is greater than 10. So negative x has to be greater than 10. So if I put an 11 in here, that would be negative 11 is greater than 10? No, that's not true. So I can't put a number greater than 10 in here for x. So let me go the other way. Let's try 9. Is negative 9 greater than 10? Negative 9 isn't greater than 10 either. So how about a negative 10? A negative 10 is positive 10. That's not greater than 10. That's equal to 10. So what if I put negative 11 here? That would make this positive 11, which is greater than 10. So that's true. So positive 11, what about a positive or a negative 12? That would be negative 12, which would be positive 12. That's greater than 10. So two numbers I just tried were negative 11 and negative 12. Negatives are tricky. Solve 2x is equal to negative 20. So 2x is equal to negative 20. So I'm just going to use my rules for solving equations. I'm going to divide by 2, and I have x is equal to negative 10. Negative 20 divided by 2 is negative 10. And then two solutions to 2 times x is greater than negative 20. So if x is negative 10 up here, this looks really similar, except this is an inequality symbol. This is a greater than, and this one's an equal to. So if I put a negative 10 in here for x, let me try that. So if I put a negative 10 in here for x, that would be negative 20 is greater than negative 20. That's not true. So let me try negative 11. Maybe that'll work. 2 times negative 11 is negative 22. Negative 22 is actually not greater than negative 20, right? This is a bigger negative number, so it's So it's further to the left on the number line than negative 20. So that isn't going to work. Let me try negative 9. Negative 9. 2 times negative 9 is negative 18. Negative 18 is greater than negative 20, so we have negative 9 as a solution. And how about negative 8? 2 times negative 8 is negative 16, so negative 16 is also greater than negative 20. Okay, problem 4.2, earning money for soccer stuff. Andre has a summer job selling magazine subscriptions. He earns $25 per week plus $3 for every subscription he sells. Andre hopes to make at least enough money this week to buy a new pair of soccer cleats. I wonder how much those soccer cleats cost. How much money does he have to make, I wonder? Let N represent the number of magazine subscriptions Andre sells this week. Write an expression for the amount of money he makes this week. So the amount of money he makes this week would be, he earns $25 plus $3 per subscription. So if he sells one subscription, he earns $28. If he sells two subscriptions, that's 3 times 2 is 6, plus 25 is $31, and so on. Okay, question B. The least expensive pair of cleats Andre wants costs $68. Write and solve an equation to find out how many magazine subscriptions Andre needs to sell to buy the cleats. So if they cost $68, this is how much Andre makes, right? This equation here, 25 plus 3n is equal to the amount of money he makes. So if the amount of money he makes is $68, the price of the cleats, how many magazine subscriptions would he have to sell? So we're going to use our equation solving skills here. So we're going to subtract 25 from each side because he gets that $25 per week. So we already earned that. And then we're going to divide by 3. So n would be equal to 43 divided by 3. It's 14 1/3 magazine subscriptions. So he probably can't sell 1/3 of a magazine subscriptions. If he only sold 14, he'd have a little less than $68. So he would have to sell 15 magazine subscriptions. If Andre sold 16 magazine subscriptions this week, would he reach his goal? Explain your reasoning. Well, if he only needs to buy 14 1/3, or if he only needs to sell 14 1/3, and he sold 16, yes, he would reach his goal. Yes, because he only needs to sell 15, and 16 is greater. So he met the goal and then went past it. What are some other numbers of magazine subscriptions Andre could have sold and still reached his goal? So anything more than 15, right? He could have sold 17, 18, 19, 50, 100. Anything greater than 14 1/3. Question E. Write an inequality expressing that Andre wants to make at least $68. So instead of making exactly $68 like he did here, we want what he makes to be at least $60. So he can make, or $68. So he can make $68, or he can make something greater than $68. So the inequality would be the amount of money he makes each week or each month is greater than or equal to, because he can make at least $68. Write an inequality to describe the number of subscriptions Andre must sell to reach his goal. So the amount of money he must make to reach his goal, what is his goal? To buy a new pair of soccer cleats. So 25 plus 3n has to be greater than or equal to his goal. Okay, so actually we want to know exactly what this number would be, right? So 14 1/3 has to be greater than or equal to sorry. N has to be greater than or equal to the number of socks number of socks. I'm looking at the next one already. The number of subscriptions he sells has to be greater than or equal to 14 1/3. So that's what they want us to do. They want us to figure out how many subscriptions he has to sell in order to reach his goal. I read that question wrong. Okay. Let's look at number 2. Diego has budgeted $35 from his summer job earnings to buy shorts and socks for soccer. He needs 5 pairs of socks and a pair of shorts. The socks cost different amounts in different stores. The shorts he wants cost $19.95. Let X represent the price of 1 pair of socks. Write an expression for the total cost of the socks and the shorts. So the shorts are $19.95 plus he needs to buy 5 pairs of socks. So 5 pairs of socks times whatever they cost, right? The price of 1 pair of socks is X. He needs to buy 5 of them, so 5 times X. Write and solve an equation that says Diego spent exactly $35 on the socks and shorts. So this is what he's spending on the socks and shorts, and we want that to be exactly equal to $35. So $19.95 plus 5x is exactly equal to $35. And we're going to solve this. So how much does 1 pair of socks cost? So we're going to solve this by subtracting $19.95 from both sides. So we end up with 5x is equal to 35 minus $19.95 is $15.05. Wait, no. No, $16.05. Oh, no, it is $15.05. What am I doing? Okay. Then we're going to divide by 5. So one pair of socks has to be equal to 1505 divided by 5, $3.01. So that's how much you can spend on each pair of socks. List some other prices for the socks that would still allow Diego to stay within his budget. So if he spends more than $3.01, he won't stay in his budget. So he needs to spend anything less than $3.01. So he can spend $3 or $2 per sock or $1.50 per sock, any number that's less than $3.01. Write an inequality to represent the amount Diego can spend on a single pair of socks. So instead of saying the socks have to be equal to $3.01, we can say the socks have to be less than or equal to $3.01. Problem 14.3, granola bars and savings. Kieran has $100 saved in a bank account. The account doesn't earn interest. He asked Claire to help him figure out how much he could take out each month if he needs to have at least $25 in the account 1 year from now. Claire wrote the inequality negative 12x plus 100 is greater than or equal to 25, where x represents the amount Kieran takes out each month. What does the negative 12x represent? So x represents the amount Kieran takes out each month. So this represents the amount he takes out each month. So what about this number, this negative 12 times the amount he takes out each month? Well, I know there's in 1 year, there's 12 months in a year. So this negative 12x represents the amount of money he takes out in 1 year. The amount Kieran withdraws, right? Withdraws is taking money out of a bank. Withdraws each year or in a year. Find some values of x that would work for Kieran. So he has $100 in there. If he takes out $1 a month, would he have $25 left in there? So let's try it. If we put a 1 in here, negative 12 times 1 plus 100, the amount he deposited into the bank. He wants that to be greater than $25 or equal to $25. So negative 12 times 1 is negative 12. So that means he took out $12. He took out $12. So negative 12 plus 100 is $88 is greater than 25. So that would work. $1 would work. What about $10? Would $10 work? If we put a $10 in here. Negative 12 times 10 is negative 120. Negative 120 plus 100 is negative 20. Negative 20 is not greater than or equal to 25, so negative 10 won't work. So, or 10 won't work. He can't take out $10 a month and still have $25 left. What about $5? Negative 12 times $5 plus 100 has to be greater than or equal to 25. So let's see if this works. Negative 12 times 5 is negative 60. Plus 100 is 40. Whoops, not equal to. Greater than or equal to. 40 is greater than or equal to 25, so he can take out $5 a month. We could express all the values that would work using either x is less than or equal to, or x is greater than or equal to some amount. Which one should we use? So this x has to be greater than or equal to 25. The amount of money, not 25. We don't even know what it is, right? We don't even know what it is, but the amount of money he takes out a month has to be greater than or equal to some amount, or less than or equal to some amount. Which one should we use? So if I look at what I did up here, 1 would work, 5 would work. I tried 10, and 10 didn't work. Right, so it has to be lower than some amount. So x has to be less than or equal to some amount here. Write an answer to Kieran's question using mathematical notation. So I'm going to try and figure out what exactly that is. So negative 12 times x plus 100 is greater than or equal to 25. So if I were to solve this the same way I would solve if this was an equal sign here, I use my rules for solving equations. So I'm going to subtract 100 and subtract 100. We'll see what happens when we do that. We have negative 12x has to be greater than or equal to, instead of using the equal sign, negative 75. Now, I'm going to divide by negative 12, divide by negative 12, so I have x is greater than or equal to a negative divided by a negative is a positive, and 75 divided by 12, 75 divided by 12 is 6.25, so 6.25. But we just said that x has to be less than or equal to some number up here, right? So we need to switch this inequality symbol around. X is less than or equal to 6.25. I wonder why we had to do that. Why did we have to switch that inequality symbol, I wonder? Okay, let's look at number 2. A teacher wants to buy 9 boxes of granola bars for a school trip. Each box usually costs $7, but many grocery stores are having a sale on granola bars this week. Different stores are selling boxes of granola bars at different discounts. Nice. If X represents the dollar amount of the discount, then the amount the teacher will pay can be expressed by 9, she's buying 9 boxes, times 7, the usual price, $7 is the usual price, minus the discount. So $9 times 7 minus the discount in whatever store. In this expression, what does the quantity 7 minus x represent? Well, that's the cost of the granola bars in that particular store, right? Different stores are selling the boxes the boxes of granola bars at different discounts. So we don't know what this x is. It could change. The teacher has $36 to spend on the granola bars. The equation 9 times the quantity 7 minus x is equal to 36. Represents a situation where she spent all $36. Solve this equation. So how much money did she spend, or what was the discount for the boxes? So 9, she's buying 9 boxes at 7 minus x. She spent $36. So knowing what we did previously, we could divide by 9. So 7 minus x is equal to 4. And I know that 7 minus 3 is 4. But if I solve the rest of this out, I would subtract 7 and subtract 7. I get negative x is equal to negative 3. That's kind of weird. But properties of equality say what I do to one side, I could do to the other side. So I'm just going to multiply this side by negative 1. And that's going to make my x positive, right? A negative times a negative is a positive. And negative 1 times any number is that number. So negative 1 times negative x is x. But since I multiplied this side by negative 1, I'm going to multiply this side times negative 1. Negative 3 times negative 1 is positive 3, so x is equal to 3. All right. X is equal to 3. So what does the solution mean in this situation? Well, x is 3, and x represents the discount. So that's the discount she got. She got a $3 discount when she spent $36 and bought 9 boxes of granola. So that's the discount of $3 per box. The teacher does not have to spend all $36. Write an inequality relating 36 and 9 times the quantity of 7 minus x, representing this situation. So since she doesn't have to spend all 36, she could spend less than 36, right? So the amount of money she spends here, 9 times the quantity 7 minus x, 9 times the quantity 7 minus x, that can also be less than or equal to 36. So she can spend less than $36. She can't spend more. We can't turn this inequality around and make this greater than 36 if that's all she has to spend is $36. The solution to this inequality must look like x is greater than 3 or x is less than or equal to 3. Which do you think it is? Well, we know that if she spends $3 exactly, or the discount is $3 exactly, she'll get $36. But what if the discount is $4? If the discount is $4, that would be okay. If the discount is $5, that would be even better, right? She'd be spending less. So x has to be greater than or equal to $3. It could be a little confusing because you think, well, she has to spend less than 36, but if the discount, since this represents a discount, then the more discount there is, the lower the lower she's going to be spending. All right, let's take some notes. How does solving an equation help to solve an inequality? So solving an equation gives us the exact amount, right? Solving an equation, it kind of gives us a starting point. It gives us a point that separates whether it's going to be greater than or less than, right? It gives us, we'll just say it gives us a separation point. Then we need to decide, if it should be greater than or less than that amount. Okay, so that value where we found out it was equal to, sometimes if we have, like with Andre and his soccer cleats, if he only has $68, he needs to spend less than $68, right? Or exactly $68. Or the socks. Or even the discount. The discount was greater than a certain amount. So to give that example, we'll go back and take an example from the work we did. Let's use this example here. So if 9 times the quantity 7 minus x has to be less than or equal to 36, we solve this by figuring out what if it was exactly equal to 36. We do the same process. We divide by 9, divide by 9, we get 7x, nope, 7 minus x. Has to be less than or equal to 4. And now I know that 7 minus 3 has to be less than or equal to 4. So x has to be less than or equal to 3. And how can you check to see if a value is a solution? Well, I can go back and I can check. I can put 2. If 7 minus 2 is 5, oh, that's right. We said it had to be greater than, right? We had to switch this around. We had to switch this one around. So, well, I'll leave it like that. So if I put a 2, 2 is less than 3. So if I put a 2 in here, 7 minus 2 is 5. 5 times 9 is 45. 45 is not less than or equal to 36. So in this case, I'm going to have to just change this around so that x is greater than or equal to 3. So I can replace that. So now 2 is not greater than or equal to 3. What about 4? So 7 minus 4 is 3. 9 times 3 is 27, which is less than or equal to 36. So to check to see if a value is a solution, you can substitute the value, the number we got here, back into the inequality. So 9 times the value of 7 minus 3, if that's less than or equal to 36, we're good. So 7 minus 3 is 4. 9 times 4 is less than or equal to 36. It's equal to.